Hello everyone. We will be starting off with NEET level questions. Let us begin with the first question. The first question says there is a fixed positive charge Q at O. A and B are points equidistant from O. A positive charge Q is taken from A to B along line AC, then CB. Then let's read all of the options one by one. The total work done by the charge Q is 0. That is true because the initial and final points are exactly at the same distance. Potentials are the same, so potential difference is 0, work done is 0. Work done by the charge Q from C to B is positive. Now, when you go from C to B, the angle between force and displacement is an acute angle, and that's why the work done would be positive. So option B is also correct. Work done by the charge Q from A to C is negative. Once again, the angle between force and displacement is an obtuse angle. This time the work done would be negative. So the option C also is true. All of them is the correct answer. So option D, right? Option D, all of them is the correct answer. Let's go further. Let's talk about the second question. 2-point charges, a point charge Q moves from point P to point S along path PQRS in a uniform electric field E pointing parallel to the positive direction of x-axis. The coordinates of PQRS are AB, AB0, 2A, 0, 0, and A, minus B, 0, and 0, 0, 0. So S is basically the origin. The work done by the field in the above process is given by. Because the work done in the electric field is a conservative force field, the work done does not depend on the path taken. So what we can do is let's move from P to this place. Let me call that point M, and then from there we can go to S, because the work done would not depend on the path that you take. So because of which the work done, by the way, is going to be F dot PM. So PM is perpendicular to the electric field, the force essentially, and that's why the work done would be 0, because cos 90 is 0. The force is in the direction of electric field. PM is in a direction perpendicular to the electric field. Cos of the angle between force and displacement is 90. Cos 90 is 0. So similarly, let's talk about our charge moving from M to S. Our charge moving from M to S. So if we move this way, now we are going to move that way. When you do that, we have W is equal to F dot MS, right? So now the angle between force and displacement is 180 degrees. So F into MS essentially is A. So if you look at it, the distance between them is A. So because Q is 2A, S is 0. So that means that particular place M is going to be 0. M is going to be A. Force is F, displacement is A, and cos of the angle between them is 180. Cos 180. So what is it that you are going to get? Q into E into A. Cos 180 is minus 1. So minus QEA is the answer you will get. Minus QEA is option B. That's how you would solve the question. So the concept behind this question is work done by, the work that you do, it does not depend on the path you take. Let's continue. 3-point charges, 1 coulomb, 2 coulomb, and 3 coulomb are placed at the center at the corners of equilateral triangle of side 1 meter. The work done to move these charges to corner A of smaller equilateral triangle of side 0.5 meter in two different ways as shown in the figure are WA and WB. Now at the end of the day, the initial triangle and final triangle are absolutely identical. So whether you get all the charges closer or 2 charges closer, because the work done again does not depend on the path taken, if the initial energy and final energy in both of these situations, A and B, the change is the same and the work done is the same, we would go with option C. Option C is the correct answer. Let's go further. Question number 4. Consider a ring of radius R with charge Q uniformly distributed over its perimeter. Potential difference between the center of the ring and a point on the axis of at a distance 2r from the center is. So we have got a ring here, that's the axis. The potential here, let's say, is VO, and the potential here, let's say, is V2R. We need to find the potential difference between these two, right? Let us find the potential difference between these two. The potential due to a ring, a charged ring, on its axis is given by kq divided by root of r square plus x square. Now, if you're talking about the center, at that case, V naught, x is 0, so you would have kq divided by r. And when x is equal to 2r, you put x equal to 2r, then the potential at 2r on the axis is going to be kq divided by r into root 5, because that's 4 plus 1, 5 under the root r into root 5. We're talking about the potential difference. Potential difference delta V would be equal to kq divided by r minus kq divided by r root 5, which is equal to kq divided by r into root 5 minus 1 divided by root 5. So I think that's option A. Instead of 15, you should make it root 5. Then it would match. So option A in this case is the correct answer. Let us go further. Question number 5. A block of mass m oscillates with a time period t when suspended vertically with the spring constant k. Now, the space between the plates is made gravity free and an electric field is produced in the direction as shown. Then the block is given a charge q. The new time period would be. The time period is basically given by 2 pi root of m divided by k. Now, the mass hasn't changed. The mass is the same, and the spring constant, which produces the restoring force, also is the same. Since that is same, irrespective of whether it's gravity or electric field playing out, the time period would remain the same. Option A is the correct answer. Let us continue with question number 6. Two identical particles of charge q are connected by a massless spring of force constant k. They are placed over a smooth horizontal surface. They are released when the separation between them is r and spring is unstretched. If the maximum extension of the spring is r dash, value of k is, we need to find the value of spring constant. Let us look at the energy aspect of this question. Initially, the energy is only in the form of potential energy of two charges. So you can write that as 1 by 4 pi epsilon naught q divided by r being the initial separation between them. The final energy of the two charges, when you let them go and when the spring is in the stretched position r dash, you would have 1 by 4 pi epsilon naught q square divided by r plus r dash plus the potential energy is spring half k r dash square. Now, since it is conserved, the energy is conserved, EI would be equal to EF. Since it is the case, half k r dash square would be equal to q square divided by 4 pi epsilon naught r into r plus r dash, right? So that's the answer you are going to get after simplifying it. You will have k would become k becoming equal to 2q square divided by 4 pi epsilon naught r into r dash into r plus r dash. Now, none of these options match with the answer that we have got. So option D, none of these is the correct answer. Let us go further to question number 7. A charge q coulomb is uniformly distributed throughout the volume of a solid hemisphere of radius r meter. Then the potential at the center O of the hemisphere in volt is. That's the question. What is the potential at the center? Now, it's quite simple a question here. The potential at the center of the sphere is 1 by 4 pi epsilon naught, uniformly charged sphere, is 1 by 4 pi epsilon naught, 3q divided by 2r. That's what it is. Now, because if you think about it, this is only half the complete sphere. If you imagine the sphere to be complete, then the charge on it would be, here it's a q, here it's a q, it's going to be 2q. So the potential at the center would be equal to 1 by 4 pi epsilon naught 6q divided by 2r. But we are only talking about one hemispherical surface. So the potential at the center of the hemisphere would be equal to half of the potential of the complete sphere. When you divide it by 2, you will again get 1 by 4 pi epsilon naught. 3q divided by 2r. 1 by 4 pi epsilon naught 3q by 2r is going to be option A. So option A is the correct answer. Let's go further. Solve question number 8. Now, two insulating plates, both uniformly charged in such a way that potential difference between them is 20 volt. So potential difference has been given, it's 20 volt. Plate 2 is at higher potential. The plates are separated by a distance of 0.1 meter. The question says D is 0.1. That's fantastic. Can be treated and can be infinitely treated as infinitely large. Both the plates are infinitely large. An electron is released at rest from the inner surface of plate 1. What would be the speed when it hits plate 2? We have to find the speed with which it hits plate 2. Let's figure out. All that matters is the potential difference. The potential difference has been given. Potential energy of the charge, which is in this case is the electron, Q into delta V is the potential energy. That becomes kinetic energy, half mass of the electron into velocity of the electron square. So if you try to find the velocity, it would be equal to root of 2, the charge is E, into delta V divided by mass of the electron. Let us substitute it here. Root of 2 multiplied by 1.6 multiplied by 10 to the power of minus 19 into 20, because that's the potential difference, divided by ME is 9.1 into 10 to the power of minus 31 kg. So the answer you get is 2.65 into 10 to the power of 6 meter per second. That's option B. So question number 8 is option B. Let's hop to question number 5. Ninth question. In which of the following cases is the potential non-zero? Now, just by examining, the plus Q here has the same potential as minus Q here, equal charges, so potentials in magnitude are the same, opposite in nature, so the positive and negative potential cancel out to give you a 0. Here also, the distance between all the three charges and the center, distance between the center and all the three charges is simply the same. So they would produce potential equal to V, meaning plus Q will produce a potential equal to V, minus 3Q will produce a potential at the center equal to minus 3V, and plus 2Q will produce a potential equal to plus 2V. So the total would be 0, and hence you can just say that the potential at the center is going to be 0. Here there is an unbalanced set of charges. There are totally 4 capital Q's plus capital Q's and 1 minus 2Q. So the potential at the center completely does not cancel out here, because due to positive charges it's 1 plus 2 plus another 2, that's 4. 4V is what you are going to have, but negative potential is going to be just 2V, and because of which the potential here is 4V minus 2V, it's going to be 2V. It's not going to be 0. So the correct option is option C. Right. Let's continue. Question number 10. A cube of metal is given a charge plus Q. Then, which of the following statements is true? Potential at the surface of the cube is 0. That's not possible. When you have given a charge, the potential will never be 0. Potential within the cube is 0. No, potential within the cube is going to be the same value as that of the surface of the cube. Electric field is normal to the surface of the cube. Absolutely true. If you have any conductor, the electric field will always make an angle of 90 degrees with it. So that's the correct answer. Electric field varies within the cube. That's not true, because it's a metal cube. Electric field inside the metal is 0. Option C is the correct answer. Let's go further and solve question number 11. Two concentric conducting spheres of radii r and 2r are carrying charges q and minus 2q respectively. If the charge on the inner sphere is doubled, the potential difference between the two spheres will become, what will be the potential difference? Now let us try and understand. Let's write an expression for the potential on the inner sphere. The charge due to the potential due to the two charges can be written as kq1 divided by r, and due to the second charge, it's KQ2 divided by 2R. It's KQ2 divided by 2R. Now, the potential on the outer sphere, V out, is going to be equal to KQ1 divided by 2R plus KQ2 divided by 2R. Now, if you try to find the potential difference is going to be KQ1 divided by 2R, because KQ2 by 2R gets cancelled. This only tells us that the potential difference is directly proportional to charge on the inner sphere. If that is doubled, then potential difference is also doubled. So the correct answer is becomes 2 times, right? Becomes 2 times. Option A is the correct answer. Let us continue. Solve question number 12. 3 concentric spheres, spherical conductors, are arranged as shown in the figure. The potential P will be, what will be the potential P at that point? Point P is inside Q3 but outside inside C but outside B and A. So let us write down the potential at that place. See, the potential can simply be written in terms of the constant 1 by 4 pi epsilon naught Q1 divided by R. That's the potential due to Q1. All right. Due to Q2, it is again, right. So potential due to the B charge is going to be equal to 1 by 4 pi epsilon naught Q2 divided by R, because that's again outside it, right? And then VC would become equal to 1 by 4 pi epsilon naught Q3 divided by whatever is the radius of C, that's C, right? So the total potential VA plus VB plus VC would become equal to 1 by 4 pi epsilon naught will come out as a common factor. Then you will have Q1 plus Q2 divided by R, and then you will have Q3 divided by C. So that's how you would compute the potentials. So option B is the correct answer. Option B would be the correct answer. Let's continue to question number 13. If electric potentials on the inner and outermost sphere is 0, then the relation between R1, R2 and R3 is. So anyway, the inner and outermost spheres is 0. Let's talk about the inner sphere. Because at the center it is 0, you can say the potential basically can be written as 1 by 4 pi epsilon naught Q divided by R. I want to write it in terms of surface charge density, so you can multiply and divide by 2. It will be sigma R divided by epsilon naught. So that's the equation that I'm going to write. Let's write down the potential at the surface of the innermost sphere. So sigma, we are calculating the potential at the center, which is basically 0. So the potential due to the innermost sphere is sigma R1 divided by epsilon naught. Due to the next sphere is 2 sigma R2 divided by epsilon naught. And due to the outermost sphere is sigma R3 divided by epsilon naught, and that's equal to 0. So if you divide the whole thing by sigma by epsilon naught, you will have R1 minus 2R2 plus R3 becoming equal to 0. So what do you think R2 would be? It is R1 plus R3 divided by 2. R1 plus R3 divided by 2 is option C. Let us go further. Solve question number 14. An arrangement of 3 large metal plates with respective charges marked in V, marked in volt, is shown in figure. Alright, fine. What is the charge appearing on the left face of the plate P? What is the charge appearing on this part of the plate? That's the question. Well, the total charge of the system now is Q1 plus Q2. So what is going to appear on left side of A and right side of C is going to be Q1 plus Q2 divided by 2. That's the total charge divided by 2. Now, if you just ask me, what is the charge appearing on the right side of A? What is the charge appearing on the right side of A? It's going to be Q1 minus Q1 plus Q2 divided by 2. That's the charge appearing on the right side of A. It would be equal to Q1 minus Q2 divided by 2. would be q1 minus q2 divided by 2. So what would be the charge appearing on the other surface of B? Same amount of charge would get induced. So the charge appearing on the left of B would be equal to negative of this charge, which is q2 minus q1 divided by 2. q2 minus q1 divided by 2 is option B. Option B is the correct answer. Let's go further. Let us do question number 15. Two short electric dipoles are placed as shown. If the distance between them is r, then the energy of interaction between the two dipoles is. Let's find out. The energy of interaction is simply U equal to minus P2 in dot E1. The reason why I write P2 dot E1 is because E1 is the electric field produced by dipole P1, and this dipole lies on its axial line. When that is the case, you can just say the angle between them is of course theta. So angle between the two electric fields, because electric field is in the same direction of dipole moment on the axial line, angle between electric field on the axial line of P1 and P2 is theta. So P2 into E1 into cos theta is what you are going to get. But now let us write down what is E1. E1 is P2 into 2p cos theta. That means 2p1 cos theta divided by distance q. Of course, there is a 1 by 4 pi epsilon naught. You can write that 1 by 4 pi epsilon naught. 2 1s are 2 2s are. So the energy of interaction would be minus P1 P2 cos theta divided by 2 pi epsilon naught r q. Right? That's what you are going to get. I think that matches with minus 1 by minus P1 P2 cos theta divided by 2 pi epsilon naught r q. Matches with option B. Matches with option B. Well, there are 15 questions in this video. We will look at the next 15 questions in the following video.